Okay, we are in Advanced Math Trig, Mod 7. It is Monday, April 6th, 2020. Hope you guys are doing well and hanging in there. It's the first day of our second week of remote learning or distance learning or online learning, whatever you want to call it. So far, you guys have done a great job. The assignments, for the most part, have been done well, have been done and turned in on time. I hope you're following along with the lesson and my explanations are making sense. Again, I would recommend that you keep taking notes so that by the end of the year, you've got a nice, neat notebook organized in order by topic that you can utilize next year if you need to, okay? Again, Advanced Math, Mod 7, 4/6/20 is the date. The topic for today, we're done with the linear and the quadratic equations that we're solving, and we're going to approach two laws. One law today called the law of sines. Tomorrow, a topic called the law of cosines. And these are techniques or formulas that were developed to help solve triangles that did not have or do not have right angles in them. So to start this topic, again, title is Law of Sines. Everybody on your notes start by making a little remember note and simply write remember and draw a nice, neat right triangle where the left side is 8 inches tall. I've got a right angle in the corner. I've got a 50-degree angle down in this corner, and the hypotenuse is my x value, my unknown. And you will remember, this is the one thing you're going to take with you from trig, no doubt. To solve a right triangle, we can use good old SOHCAHTOA. So if I said, let's do this problem based on what we remember doing earlier in the year, does everyone agree we would start at this 50-degree reference angle in this corner, and it looks like we're going to use what? The opposite side and the hypotenuse, agreed? And opposite over hypotenuse, if you remember, SOHCAHTOA was what? Sine, wasn't it? So I would end up writing the sine of 50 degrees equals 8 over x. We would certainly put him over 1, and we would cross multiply. So I would end up with x sine 50 equals 8. And then, of course, to get x by itself, I would divide by the sine of 50. I would divide by the sine of 50. Those would cancel. And x would end up equaling, go ahead and take your calculator. Push 8 divided by the sine of 50. I'm doing that right now. 8 divided by the sine of 50. And it looks like 10.4 would have been the missing hypotenuse on that problem. Piece of cake. It's not supposed to be difficult, but it's a review of what we've already learned. And we loved using SOHCAHTOA when we had a right triangle. But the question of the day. Put a star and write, well, what if my picture would have looked like this? So guys, problem number 1 today. Go ahead and make a triangle, but notice I've still got this side being 8 inches long, and I've still got this angle being 50 degrees down here at angle A, but instead of a right triangle, this corner is 70 degrees. So my question is, how big would side B be over here, and how big would side C be down here on the bottom? How do we find the missing sides of a triangle if it's not a right triangle? Obviously, we can't use SOHCAHTOA, right? Because we don't have a hypotenuse. So a hypotenuse was defined, if you'll remember, as the side that's across from the right angle. Well, if this doesn't have a right angle, it also doesn't have a hypotenuse. So SOHCAHTOA is useless in this scenario. Well, guys, what we end up doing is using something called the law of sines. And the law of sines is simply a formula that was developed that ends up being a proportion that you're going to create. And the rule is this. I'm going to put a big star And the rule for the law of sines says, take side A and put it over top of the sine of angle A. And set that equal to side B over the sine of angle B. Or you could set one of those two equal to side C over the sine of angle C. So bottom line is, you're going to pick a side on that triangle and put it over top of the sine of the angle that's across from him and set it equal to any other side on that picture and put that over top of the sine of the angle that's across from him and create a proportion to solve your problem. Looks horrible, but watch how simple it truly is. Here we go. Let's say that we want to solve for side B on this picture. So let's ignore C for a second and pretend it's not even there. We're looking at this picture just like we were looking at that picture above it. If I said let's use the law of sines, here's all you got to do. Take one side of that picture. Well, obviously, guys, they told us this side was 8 inches long, correct? So I'm going to take that side that's 8, and I'm going to put 8 over top of the sine of, and then all you do is go across from that side and pick the angle that's across from him, which is 50 degrees. So it's always a side over the sine of the angle that's across from him. So 8 over the sine of 50 equals, now remember we said we're looking for side B. So B is the side that we use now. And of course, what angle is across from him? 70. So we would put the sine of 70. Oh, A over the sine of A equals B over the sine of B. And you solve any proportion by cross multiplying. So when I cross multiply, I've got B sine 50 equals, cross multiply the other direction, 8 sine 70. Of course, we're trying to get B by itself, so I can divide by the sine of 50, and my calculator can now do all the work. Now, guys, be careful. Huge piece of advice here. When you use your calculator, don't try to type all that in at one time. It's too easy to forget a parenthesis or a set of parentheses, and it'll mess up my advice, just hit 8 sine 70, the top value, and hit enter. And now that you've entered the top, now push divided by sine 50. And you should end up, nearest tenth would be fine, with 9.8. And we've got side B. Now I know what somebody's thinking. Oh, since we now know side A and we know side B, we can just do A squared plus B squared equals C squared and use Pythagorean theorem to get C. Incorrect. Remember, Pythagorean theorem only works if what? If it's a right triangle. Again, this is not a right triangle. So the only way to figure out how big is side C is to once again use this little trick called the law of sines. So let's attack this again using side C this time. Wouldn't we still take 8 over the sine of, who's across from him, 50, set it equal to this time C over the sine of, now don't panic, you know if that was 70 and that was 50, that's what, 120? Oh, so that would make the missing angle 60 degrees. So we're going to go C over the sine of 60. Cross multiplying, I would have C sine 50 equals 8 sine 60. I'm trying to get C by itself, so I divide by the sine of 50. And C equals, okay, again, my advice, hit 8 sine 60, hit enter, and now that you've entered that, divide by sine 50, and we get 9.04, so 9.0 for for the answer for C. And notice it worked out so that the littlest side was across from the smallest angle. The second smallest side was across from the second smallest angle. B ended up being 9.8, so that was the biggest side, which of course is across from the biggest angle. My point being, make sure your answers make sense when you find them. Okay? 2 more teaching points and we're good. Go to your paper. Call this problem number 2. Make another triangle that is not a right triangle. This time put 65 degrees in corner here for angle Q. Side W is 7, side Q is 9. What if they ask you to find the missing angle instead of a missing side? Okay, we can still do this, watch. Obviously, if you look at that picture, we know this side was 9 and the angle across from him is 65, agreed? So couldn't I, using the law of sines, put 9 over the sine of 65 equals, now the other side we have to work with is 7 over, and I don't know how big angle W is, do I? That's the one we're trying to find. So I put sine of W. So I'm still setting up a proportion. Cross multiplying, I end up with 9 sine W equals 7 sine 65. Notice I'm trying to get this sine W to be by itself. That's my unknown. So I divide by 9 and end up with sine W equals, okay, follow my advice again. Type the top in only, hit 7 sine 65, hit enter, and then push divided by 9. Now on my screen it says 0.7049 blah, blah, blah. Guys, that is not the answer to the problem. Remember, we're looking for angle W. Oh, anytime we're looking for a missing angle, we got to hit the inverse button on our calculator, the second sine button. So guys, we are actually going to hit now, since we're looking for angle W, a missing angle, we're going to hit second sine and then type in 0.7049. And we're going to end up with angle W equals, my calculator says 82. So 44.8 degrees, proving that you can certainly find a missing angle by using the law of sines, just like up top we found the missing side. And finally, the last point of the day, what if your triangle is an obtuse triangle instead? Well, example 3, last thing in your notes. We've got triangle ACT. Angle A is 118 degrees. Angle T is 22 degrees. Angle C, we don't know it, but we certainly could calculate it, correct? If that's 118 and that's 22, you add them together, you'd get 140. So if I asked you to find angle C, we certainly would know it's 40 degrees. I'm just saying, what if they said find A and or find side T? Find whichever one of those sides that you want to. Let's just practice one more problem by picking one or the other. Okay, let's go ahead and find side A. If we're trying to find side A, I would put A over, okay, what angle is across from him? Well, I go over here and see that it's 118. So A over the sine of 118, agreed, equals, now certainly we can't go and put T on the other side, because then you've got a proportion with an A and a T, and you can't have two unknowns in the same proportion. So we're going to pick the side we do know, which is 8 over, good thing we found that. If we go across from side 8, we have angle C, which we just said is 40. So you put the sine of 40 degrees. So A over the sine of 118 equals 8 over the sine of 40. Cross multiplying, I get a sine 40 equals 8 sine 118. I'm trying to get a by itself, so I divide by the sine of 40, pull out my calculator, and let him do all the work. So I'm going to type 8 sine 118, enter, and then divided by the sine of 40. And it looks like we get 10.98, which rounds off to about 11. So side A on that picture would be 11 inches, 11 centimeters, 11 units long. Okay? So that's a topic called the law of sines, used to solve triangles that do not have right angles. Pretty creative, works out great. Your job is to simply solve a proportion once you set it up correctly. All right, for homework, you're going to try these 3 questions. All right. I hope they can all fit on here. Again, Advanced Math Mod 7. Today is April 6th. Your homework are these 3 questions right here. 1, 2, and 3. Problem number 1, make a triangle. Triangle QRS. This side's 11 centimeters. This angle is 70. That one is 62. And you're looking for side S and side Q both, just like I did on the first problem. Okay? So find side S and find side Q. Problem number 2 is triangle FED. This side is 6, this side is 8.2, this side is 7.5. That angle is 50 degrees. All you've got to do on this picture is simply find angle E. How big is angle E on that picture? Find the missing angle. That's it, nothing else. And finally, the obtuse picture at the bottom, triangle AGI. You've got angles of 115 and 20. This side across from the obtuse angle is 13 inches long. You got to find side G and find side I. So guys, there's your 3 homework problems. Make sure you get them all copied down. It's Monday, April 6th. This is due, as always, the next day. I'm asking you to do 3 problems, not even due till the next day. So that'd be Tuesday, April 7th at 12 o'clock. Okay? Great job. I hope that makes sense. We'll see you tomorrow.